Hello everyone, welcome back. I'm so excited to be part of you this year. So this is our first lab in 2024. So happy new year and let's enjoy learning this year. In this our lab, we are going to configure the lab for Huawei ICT competition 2021-2022 regional final. So we're going to look at the lab. So please remember I will attach the link where you can download the lab in the description section. So this is the Huawei ICT Competition 2021-2022. What we are required to configure are these steps you see here. So we will configure MSTP DHCP OSPF as security policy on firewalls. We will also configure security protocol work in not standby mode, configuring NAT on the firewall, configuring WLAN, configure QoS, and also configuring automation. What from this our lab, we have got our headquarter and also our branch. We'll configure our, first of all, we'll consider our headquarter, then later on we will configure our branch and also our service provider, that is the ISP. So from this lab here, it's one in such a scenario where we'll first deal with the headquarter is when we'll go to branch. So branch configuration involve configuring IP addresses, configuring OSPF, and also configuring the firewall. Also, we'll have to configure, finally, the last step will be ISP. That will, in ISP, will be working on ISIS. So then I will ensure that communication is there between the HQ and the branch. Also, we are required to configure IPSec VPN to link the HQ and the branch. So that's what the lab requires to do. So as you can see from the topology here. So let's look at the background. A large enterprise has a HQ and a branch 1. The HQ network provides wired and wireless access to employees. To improve network security, firewalls are deployed at the egresses of the HQ and branch networks. To improve reliability, hot standby is enabled at the HQ. To ensure communication between the HQ and branch, IPSec VPN needs to be configured. So you can see that's the topology that we've set on that our ENSP. The devices that you are required to have is 3 USG firewall 6000V. You have got 4 AR routers, so these are the required devices. You ensure you set on your lab. Our firewall initial configurations are this one, but you will be required to change it to Huawei out 123. So because I always want the video to be very short, so the configuration involving this setting up the link type and also giving IP addresses to respective interfaces, I have pre-configured them. So because these things we have done them several times, and I believe now you are in a position now to do them on your own. So once you get the lab, just first of all, what you need to do is now to set up the layer 2 and also the layer 3 configurations for the IP addresses and the VLANs. The only part that I'm going to show you that might bring confusion is just this part here. So from this our planning, it might confuse you because you might be asking yourself, how is it that gig 0/0/1 with the VLAN 3 has the IP address? So here what they are trying to imply is that on gig 1, we are going to configure it as an access port, and it's going to allow VLAN 3. On the same switch 5, you're going to configure gig 2 as an access, and it's going to allow VLAN 4. And we are going to configure VLAN if interface to have this IP address. The same to gig 3. So you can get just into our switch 4. Let's start it and see if what we are talking about are things that have been set on those interfaces. So any interface that connects from a router, from a switch to a router, that one will act as an access port. And any interface that connects from a terminal device to a switch or a router those one will also act as access interfaces. So on access interfaces, you have to know how to configure when you have to allow that VLAN port default VLAN which you have been given. So that is the lab requirement. Let's wait the switch to start so that I show you that all the configuration for those interfaces have been configured. So we'll just go straight away to what the lab specifically requires us to do. As we wait for that, I can also show you something here. While you come to switch number one here, switch number one here has got how many interfaces? That is gig 1, gig 2, gig 3, and gig 4. But from the lab planning, it has only showed for gig 1, gig 2, and gig 3. But you have not been given for gig 0/0/4. So also, like from this our planning here. So what we are going to do is that gig 4, ensure that gig 4 here allow VLAN 101 to 103. And also there's an empty gig 103. Let's see not gig 103, gig 0/0/3 is this interface that connect to the downward interface. This one must be a trunk port, allowing VLANs 101, 102, and 103 to pass. Then gig 0/0/4 will act as our access port because it connects to the terminal. So you might find that this switch that we've used here, it has only 2 gigabit interfaces, that is gig 1 and gig 2. So other interfaces you can just use Ethernet, there will be no problem with that. So having done that, having showed you those simple places where you might get confusion, because when you also come to switch 4, gig 3 is empty. So those are the configuration that need to be. You are just required to allow pass VLAN 1 to 103. So we want to check if the configuration we were talking about are already on the switch. So this see you can see here already we have got VLAN if interfaces have been configured. Then when you scroll down, we want to see if they have been configured with access port. So you can see here, interface gig 103 have been configured to allow VLAN 5. So, but gig 1 and 2, they have not been configured. Gig 1 is this one. Then Ethernet 1 should also be configured with our respective VLAN. So let's go back and do that straight away before we proceed. So gig 1 supposed to have VLAN if that one, gig 2 VLAN if 4, and gig 5 as that one. So system view, so enter interface gig 0/0/1, tell it port link type, access, and then it tell it port default. VLAN here will be VLAN 3. Then enter for Ethernet. Let's see. So Ethernet 1 here, this one will also act as an access port. So quit. So interface Ethernet 0/0/1, port link type here will be access, then port default VLAN 4. So that's actually what they require from this our planning. So you just need to know how you interpret your IP plans. So let's now jump straight away to the actual configuration. So configuration tags, we are going to configure headquarter first. So we are required now to first of all start with the MSTP configuration. So step 1, create VLAN 101 to 103 on switch 1, switch 2, switch 3, and switch 4, and enable STP protocol, and also configure switch 1 as the root bridge and switch 2 as the secondary root bridge. Create MST region name Huawei and allow packets from VLAN 101 to VLAN 103 to be forwarded on the MST region. Enable root protection on a designated port of the root bridge. So I believe we have done several configurations on MSTP. This one should be very simple. So we are going to start our switches. I can see our devices have been started successfully. You can see the interface are turned to green. So since the software that I'm using to record this video is very heavy and running concurrent with the ANSP might somehow make our PC to lag. So we'll just persevere with the situation and just get what is important, that is grasping the concept. So we are going to start with configuring our MSTP. So before we begin that, let's see what is configured on this switch. So this CU. So already now we have set our VLAN from VLAN. Let's see. We've configured our VLAN batch from VLAN 100 or 101 to 105 as per the IP plan now, but the MSTP required us to configure VLAN 1 to 103. That is meaning that it has been considered on that VLAN batch, and the interfaces have been allowed to allow the respective VLANs to pass. So let's just begin with the MSTP, being that the interfaces have been configured with the IP addresses. So here we are going to first of all to enable STP. So STP enable. Let's first of all undo terminal monitor. So we have enabled STP. So STP here, this switch will act as the root bridge. So STP instance 1 will be the root primary. Then select STP mode here. We are using MSTP. Then set the region configuration, STP region configuration. Region name will have to give it Huawei as the practical suggested. Then instance 1, we are going to bind VLAN 101 to 103. Then tell it active region configuration for the configuration to take effect. Then display this to see if the configuration has been bound to that switch. So with that, we are done with that switch. Then we come to our secondary switch that will act as this backup for the root bridge. So UTM, then STP enable. We already configured the VLAN batch for VLAN 101 to 103. So STP mode here will be MSTP. STP instance 1 root secondary, because the other one was root primary. This one will be the root secondary. Then STP region configuration. STP region name here will be Huawei. Then instance 1 VLAN 101 all the way to VLAN 103. Active region configuration, display this. That one is done. We quit and go to the other two switches. So STP enable, STP mode MSTP. So here we are only going to configure the region configuration. So STP region configuration, region name here will be Huawei. Then instance 1 VLAN 101 to 103. Active region configuration. Go to switch number 4 and do the same. UTM STP enable, STP mode MSTP, STP instance, STP not instance, STP region configuration. Region name here will be Huawei, and active region, not active region configuration, give it instance 1 VLAN 101 all the way to VLAN 103. Active region configuration, So and our last part required us to configure root protection on the designated port. So come here and display STP brief. When you display STP brief on instance 1, both the interfaces are designated ports. So gig 0/0/2 and gig 0/0/3 are designated ports. So we come and enter those interfaces. So we are going to enter those interfaces in batch form. So port group member will be gig 0/0/2 to gig 0/0/3. So tell it STP root protection. So you can see a root protection have been entered on both those two interfaces. So go back, quit, and display STP brief now. You can see now it has been enabled with root protection. Okay, that is now great. Initially, when we displayed that protection was none. So meaning that our designated ports have now been enabled with the root protection. So we go to switch number 2 and see what the interfaces represent. So STP, display STP brief. You can see here gig 102 will act as the root port. The root port provide a backup for the designated port because we said switch number 2 will act as the secondary root bridge. So its interface that connect to switch number 1 will be the designated port. Then our designated port is gig 103, gig 0/0/3. So that's where we configure root protection. So interface gig 0/0/3. So tell it STP root protection. We are done with that. So let's go back to our practical and see if our first step is done. So enable root protection. So that one is done. So we are done with our MSTP configuration. Next, we are going to go to task number 2 was saying that configuring IP addresses, that is has been done on the table. So configure IP addresses for interfaces on the network topology as shown in table. That one and that one, planned IP addresses. That one I think it is configured. So also you should ensure that you do that first before even you configure the MSTP. Now we are going to task number 3, which says is configuring DHCP to assign IP addresses to the host. So switch 1 functions as the gateway of HQ intranet and has DHCP function enabled to allocate IP addresses to devices on the HQ wired and wireless networks. On switch 1, create DHCP service based on the interface address pool to assign IP addresses to AP1, AP2, and STA and PC1. The IP address pool for STA and PC is 192.168 blah blah those ones, and also as this one 101. We have been given them with the gateway, this one, and our DNS is set to 114. So that one is what we are going to configure on our switch 1. So we said switch 1. So this one will be where we configure our DHCP. So first of all, enable DHCP enable. So IP pool here, we'll give it a name of, first one we said was PC STA, PC underscore STA. Then our network was 192.168.102.0, the mask of 24, and its gateway list will be 192.168.102.1. Also, we said the DNS list will be 114.114.114.114. quit and create the second DHCP pool. So IP pool for the APs, we'll give it a name of AP. Then network of 192.168.101, because VLAN 101 is where the AP belongs, .0, mask of 24, gateway here will be 192.168.101.0.1, not .0.1, 192.168.101.1. So DNS list of 114.114.114. Quit and enable the interfaces to select DHCP. So enter interface VLAN if 101, tell it DHCP select global, then enter interface VLAN if 102, tell it DHCP to select a global. Then we start this our PC and see if it will be able to obtain an IP address. So first of all, we have to ensure this interface Ethernet 0/0/4 has been configured as an access port. So enter. So interface Ethernet 0/0/4, display this. It has not been configured with anything. So tell it port link type access, then tell it port access, port default. VLAN here will be VLAN 102, that is VLAN where STA and AP belong. So it should allow that VLAN 102. So after that, we come to our PC and see if it can obtain an IP address. Ensure that the option is selected as DHCP, then you apply. Then come to your command here and type IP config. Let's renew again. Let's wait. So display DHCP statistics. 4 discoveries have been made. 1 request. Of course, the link was still down. You can see now it has obtained an IP address of 192.168.102.254, meaning that our DHCP has been successfully configured, and our DHCP is working for the PC, the STA, and the AP. For the STA to obtain an IP address, we'll have first of all to configure WLAN. So that one will come up later, not now. So let's proceed. So we're done with the MSTP. Our module 1, we normally divide these labs into different modules. So module 1 was to cover MSTP, DHCP, and OSPF, and also configuring the firewalls, because for OSPF to fully establish neighbor relationship, it will have to configure the firewall zones. So we are going to start our firewall and ensure we configure OSPF. The lab says enable OSPF on firewall 1, firewall 2, switch 1 and switch 2, and set the OSPF process ID to 1. Enable OSPF on gig 101.104 of firewall 1, that is the sub interface of firewall 1 and firewall 2, and also VLAN if 104 and 105 of switch 1, as well as VLAN if 105 and of switch 2, and these interfaces are on area 0. Then step 3, configure routing policy on switch 1 to match the routes to the network segment where PC1 and STA resides, and apply the routing policy when OSPF imports user routes. So we are going to configure OSPF now. First of all, let's save our configurations. Then save on our main device. Like I said, some parts will, so because we won't need switch 4 and switch 3 when configuring OSPF, we're just going to stop them, because when we start our firewall and run with the software, it will become so slow. Will take a lot of time configuring the OSPF. So we'll just stop those two devices and start our two firewalls, because our RAM is small and it won't support a lot of things. So our firewalls are started. As you can see, the interface that links them are green. Now let's enter into our firewalls and do the OSPF configuration. Admin, then you're going to type the password that we already changed, that was Huawei. Admin, then password was Huawei. Shift at 123. So let's first of all start with configuring OSPF on our switch. So we said here we are running on OSPF process 1. So OSPF 1 area here will be area 0. On area 0, on switch we will to configure OSPF on VLAN if 104 and 105. So we're going to set that. So the interface is lagging because we are running concurrently with our firewalls. That is why you can see it hangs a lot. OSPF 1. Before we configure OSPF, let's quit and enter interface. There is a sub interface that's been configured on that our firewall. So sub interface gig1/0/1.104. display this. It has an IP address, but the interface is still down. So we're going to bring that interface up by telling it VLAN type .1q termination with 104. So you can see here the interface has entered an upstate. Initially it was still down. So if you don't configure that, the LSA won't be able to establish. The interface must be up. So you quit and go back to our switch. Here we are going to tell it network of 192.168.104.0 with a mask of 0.0.0.0.3, because this one is /30, so its wildcard mask will be 0.0.3. That one is for VLAN if 104. Then for VLAN if 105 will be a network of 192.168.105.0, the mask of 0.0.0.0.3. Enable terminal so that we can see it exchanging LSS. Then we come to our firewall and configure OSPF 1. Area here will be area 0. We're going to advertise the network of 192.168.104.0. that is on a sub interface of 101.104. I'll go and mask of 0.0.3. So it has exchanged LSS, but why is it that is not establishing a full state? It is only ends at extart. This is because we have not configured the firewall zone. So after we configure the firewall zone, we'll see the LS being establishing a full state. So let's proceed and configure also OSPF on switch number 2. Then later we'll configure the firewall zone. So terminal monitor, OSPF here, OSPF process 1, area 0, network of 192.168.105.0, mask of 0.0.0.3. This will establish a full state with the peer. You can see it's established a full state. So then a network that connect to VLAN if 106, so 192.168.106, that establishing a peer with the firewall number 2 0 0.0.0.3 and enter this firewall admin Huawei at 123. So enter interface gig 1/0/1.106. Display and see its IP address as the IP address of 192.168.106.1. So we're going to tell it VLAN type to bring that interface up. .1q VLAN 106. Quit and configure OSPF. So OSPF 1 area 0 network of 192.168.106.0, the mask of 0.0.0.3. Can see it has started advertising the OSPF packets, and the state is at extart. So we want to ensure that the state is established to be full. So before we finish configuring the OSPF, so step 1 was to enable OSPF on those firewall and the switches. Step 2 was to enable OSPF on those interface. Step 3 is requiring us to configure the route policy to match the routes to the network where PC1 and PC2 belong. But before we configure that, we are going to configure the firewall zone so that the neighbor state is established to be full. So let's do the configuration for this security zone on firewalls. Then here we are required step 1, create security zone name ISP, set the priority to 15, add gig 100 to the zone to connect to the ISP, create security zone name heart, priority is 75, and we are going to add the heartbeat interface, that is ETH trunk 0, then add interface gig 101 to each sub interface to the trust zone. So gig 101 and each sub interface we're going to add to the trust zone. So we come to our firewall 1. We're going to quit again. So firewall zone name here will be ISP. Set priority to 15. Quit, and not before we quit, we're going to add interface. So add interface gig 1/0/0. Quit and enter firewall zone name here will be heart. Set priority to 1 to 75. Then we are going to add the heartbeat interface, that is trunk 0. Add interface ETH trunk 0. Quit, and we are going to add the gig 101 and its sub interface into the trust zone. After we configure that, we will see it establishing a full state. So firewall zone trust, add, because the trust zone already has the default security priority configured. So we are going to add interface gig 1/0/1 and also add interface its sub interface gig gigabit ethernet 0/0/1.104. You can see here it has established a full state after we configured the security zone. So we come and do the same to our firewall number 2. So quit again. Firewall zone here was name, we gave it ISP. Set priority to 1 to 15 5, and add interface gig 1/0/0 gig 1/0/0 and quit. So firewall, so we name it firewall zone name to be heart. Set a priority to be 75. Add interface ETH trunk 0. Quit and create firewall zone trust, then add interface gig 1/0/1 and also add interface gig1/0/1.106 should establish a full state. The neighbor state is now full. So we are also done with the firewall zone configuration. So as the practical just suggested. So that was task number 5. But task number 4, we didn't conclude our last part. That was configuring routing policy on switch 1. So we come back to our switch number 1. We are going to configure our routing policy. So we enter that our switch. First of all, to configure our routing policy, we are going to configure our SCL. We are going to use the basic SCL because we are going to allow the source IP, that is 192.168.102.0, where the PC and the STA reside. So create SCL 2000, 2001, and on that SCL we are going to set rule number 5 to permit a source address of 192.168.102.0 with a mask of 0.0.255. After we configure that, quit and now create the route policy. So I'm going to create route policy. Route policy here, we are going to name it PC to STA, and we are going to permit node number 10. Permit node number 10. So the source. So on the node number 10, if it matches the SCL, if it matches the SCL 2001, we're going to tell it to apply preference value of 200. So apply local preference of 200. So in case it matches that, should apply local preference of 200. So having configured that, now let's now apply the route policy when importing OSPF routes, because we were told to apply it when importing the route into OSPF. So quit. We're going to enter OSPF1, and we're going to apply the route policy when routes are being imported. So on OSPF1, we're going to import route static route policy. The route policy name was STPC. Import route policy and question. So import route policy. When you tell it import route policy and you question, you can see here our route policy that we have just configured PC to STA has been added into our selection. So we are going just to pick that we need to import PC to STA. That one is the one that we just created up there. So display this. You can see it have been applied when importing the routes. So I think having done that, we are just through with our module number 1. That was to implement MSTP, configure DHCP OSPF, and also since we wanted the firewall to establish a full state with the switch, we had to configure also the security zones for the firewall. So we are done up to task number 5. So in our next module, that is module number 2, we are going to pick from task number 6, that is configuring firewall to work in hot standby mode and configuring NAT on the firewall. Then module 3 will tackle WLAN because we are still on our HQ network. Then we will go to quality of service, then configure network automation. Then after we are done with our main headquarter network, we'll venture into our branch network and configure our branch. So far, I hope you guys are enjoying the session. If you are still with me here and you are still new to the channel, remember to subscribe. Also remember to give me a thumb up to support our content production. Thank you for being part of us, and continue enjoying your learning, and let's meet in our next module. Bye bye.